Okay, so now that you know the 5 congruencies of a triangle, we can put that all together into one final acronym, CPCTC, which just stands for congruent parts of congruent triangles are congruent. Just a way to abbreviate that so you don't have to write it all the way out. Essentially, what that means is that we can use these triangle congruencies to prove that 2 triangles are congruent. And then we can use the fact that 2 triangles are congruent to figure out what other parts are congruent as well. All right, so whenever you're starting out with a proof that involves a diagram, make sure that you mark everything in the diagram. So you can see here that RJ is congruent to RK. We're going to mark that then. So RJ is here. That's congruent to RK, which is here. So we start with 1 tick mark. Then SJ is congruent to SK, so we mark that as well. That's all we know, but we also know that RS is congruent to RS, so we could even go ahead and mark that. So typical proof here, we start with our first statement, which is always the given, right? We end with our what we're trying to prove, so you can see here what we're trying to prove. In the middle, we have RS is congruent to RS. That's what we talked about up here. We know that because of our reflexive property. All right, so you can see by our markings then that these 2 triangles are congruent. And you just state the reason. So this one is side, side, side. So you can see it's really just marking what you know and then working through the proof as you typically would. All right. So let's try another one. Given K is the midpoint of CD, so here's CD. AK is congruent to KB, so we know that this AK here is congruent to KB here. Because K is the midpoint of CD, we also know that C to K is equal to K to D. We also know that this angle is congruent to this angle because they're vertical. All right, so there's a lot of things you could go ahead and mark in your triangle before you even, in your triangles, excuse me, before you even get to the actual proof. All right, so again, starting out with your given information. And then essentially you're stating, if you look at the diagram and at the statements, you're going to state why you were able to mark those. So if you mark up your picture first, that can make this process a little bit easier. So why were we able to mark CK congruent to DK? Well, that again was because of that word midpoint. So we can put definition of midpoint. And then it says angle CKB. So this angle here, CKB, is congruent to angle DKA, which is this angle here, which we already had marked. Why did we have those marked? We had those marked because they're vertical angles. And vertical angles are congruent. And so then we can look at our markings and state why these 2 triangles are congruent. So we have a side, an angle, and then a side. That same side, an angle, and then that other side. Oops, I did that. So that's and then side, angle, side. Okay, I want you to go ahead and pause the video and try this one yourself. I want to remind you though, real quick, that the word bisects means to cut into 2 equal parts or in half. Okay, so go ahead and give this one a go. Okay, here you go. If you turn back a page, you'll see this one is pretty similar to the first one that we did. So you have your given, the definition of bisect is why those two are equal, your reflexive property, and then so now all three sides are equal, so these triangles are congruent by SSS. Okay. The other thing that is important is to be able to just recognize the reason that goes with a statement. So we've worked a lot with proofs, and we've done a little bit of matching with them, but just being able to match these up. So when you see a statement that says like MO is congruent to MO, you know that that goes with reflexive property. So just identifying stuff like that will help you to fill in your proofs a lot faster. We can see up here our given information. So we know like 2 goes with D because that matches our given. And so really then it's just a matter of matching the other two up. Our reason that our triangles are congruent is going to be what we're trying to prove in these particular cases. And so that leaves our last one, definition of angle bisector. Well, that's describing two angles that are congruent. That again makes sense, so we can match those up as well. Okay, so we know what statement goes with which reason. Now we just need to put them in order. Okay, well, obviously our given needs to go first, and what we're trying to prove needs to go last. So our given goes first. D goes with 2, so we put a 2. What we're trying to prove goes last. That goes with A, right? In these types of proofs, most of the time, and there is a few exceptions to this rule where one needs to follow the other. Most of the time, though, the order doesn't matter in the middle. So for this one, definition of angle bisector, which is what we used for this, and reflexive property, which is what we used for this statement, neither of those has anything to do with one another. We don't need one to know one to be able to state the other. So you could either put a 1 and a 4, or you could put a 4 and a 1. It doesn't matter which way you go for that. Just again making sure that you match up those statements with those reasons. So if you do 1, make sure you say C. If you do 4, making sure you say B. Or if you go the other way around, making sure you flip that. Okay, so just know that order here in particular doesn't matter. Okay. All right, so CPCTC stands for congruent parts of congruent triangles are congruent. Okay, so what that means is we can take the fact that two triangles are congruent and determine other congruency statements from that fact. So for example, we know that L is congruent to N because that's given to us. Angle LMO, which is this angle here, L to M to O. So this angle here is congruent to OMN, so O to M to N, this angle here. Those are congruent. And we know that MO is congruent to itself for a reflexive property. So now we know that these two triangles are congruent by angle, angle, side. All right, well, if the two triangles are congruent, that means that all of its congruent parts are also congruent. So we can now mark anything else that we want. So we know that, for example, LM is congruent to MN. We know that NO is congruent to LO. And then we also know angle-wise that this angle here, and because O is split, we'll have to name it with 2 letters. So LOM is congruent to NOM. And I think that's all we didn't know. So we have 1, 2, 3 angles. And 3 sides. Okay. So the purpose is that you can know for certain that other things are congruent, and that helps you set up problems and solve them if you can first prove that the 2 triangles are congruent with what you have to begin with. All right, so here's an example of where we're not trying to prove 2 triangles are congruent, but somewhere in our proof we're going to use that. Okay. So we know that AC is congruent to EC. Again, we're going to mark that. We know that this first statement is going to be our given. We know that BC is congruent to CD, or DC, however you want to put that. We know that these 2 angles are congruent, which if you look down in your proofs, if you're doing this at the same time, ACB is congruent to ECD, ACB, ECD, because they are vertical angles. And so if you look at the triangles now, we know that ABC is congruent to EDC by side, angle, side. All right, so you have a side, an angle, and then a side. There's the same side and angle, and then a side. So side, angle, side. Well, because those 2 triangles are congruent, automatically angle A is congruent to angle E. The reason that we're going to give for that, though, is that congruent parts of congruent triangles, corresponding parts of congruent triangles are congruent. I said congruent up here, didn't I? Yeah. I'm sorry. You'll have to forgive me for that. Corresponding. Corresponding parts of congruent triangles are congruent. All right, so same position, right? A is congruent to E, AB is congruent to ED, right? We've talked about those congruency statements before. Okay, again, push pause and see if you can fill this one in. Okay, and here's this proof. You have your given. Knowing that those sides are parallel, we can then mark our alternate interior angles congruent. This one is reflexive property. I know it looks a little different because these are flipped around, but that's okay. It's still reflexive property. So we have an angle, and then a side that are marked congruent. And once you know those triangles are congruent, then all of your corresponding parts are then congruent. Okay, we are going to go over these last 2 in class. I want you to go ahead and try them yourself. All right, so mark this. Remember, bisects means cut in half. So this is cutting angle RQT in half. Go ahead and try this proof. And then this one is like the one we did earlier. Match your statement with your reason, and then put them in the order that they belong. All right, have a good night.